Hello everyone, my name is Vishakha Kshatriya and I am from GH Raisoni College of Engineering and Management, Wagholi, Pune, from the Department of Artificial Intelligence. Today I am going to represent our final year BTech project, that is Venom Alert, along with my teammates, that is Atharva Palaskar and Sejal Wankhede, under the guidance of Professor Bhagyashree Wankar ma'am and our esteemed HOD Dr. Rachna Sable ma'am and our respective campus director Sir Dr. R.D. Kharadkar. So let's go through the video. So these are the different contents which are included in our presentation, that is introduction, detailed statistics, literature, survey, methodology, results, conclusion, and then references. So let's start with the introduction. There are thousands of deaths are occur annually due to the snake bites. Also, there are different kinds of injuries occur due to the snake bites, and the injuries include like health injuries and heart damage, kidney damage. So at that time, first aid treatment is required for that patient, or immediate doctor treatment is required for that particular patient. So for doctor, it is also important to know that which kind of species of the snake that is, whether it is a venomous or whether it is a non-venomous. So according to that, they can order the right antivenom for the treatment of that patient. Rather than that, if generally people, whenever people generally see any snake, they directly kill that snake. So it also leads to disturb in the ecological chain of Earth. So our aim to address the thousands of snake bite related deaths and injuries annually, and also we build a AI powered platform for identification of different kinds of a snake species and also whether they are venomous or non-venomous. So functionality is users can upload the snake images to the website. It gives the correct and accurate identification of the different species of the snakes, and it also classify whether the snake species is the venomous or a not venomous. We use the different technologies like machine learning algorithms and a comprehensive database, and our goal is to reduce the snake bite related deaths and disabilities. Let's come towards the detailed statistics. These images show the detailed statistics of a deaths which are occur annually. Uh, in year 2019, there are 2,936 deaths are occur. Death rate is a 25%. In 2020, death rate is a 22%. Like 2021, the death rate is a 20%. In 2022, it is 21%, and in 2023, it is a 12%. And these are the target audience which generally face the snakebite issues. We see the methodology of our project. These diagrams show the overall system architecture of our project. The first block shows the user interaction, that is UI layer. UI layer is a combination of HTML, CSS, and JavaScript. User can upload the image on the UI layer, then image handling and JavaScript trigger. That is this is image upload event. Then it goes. We use the Flask API for the connection of a model with the UI. Then image processing is done, then it identify whether then it identify the species of the snakes, whether the species is a venomous or a not venomous. Then image processing is done and the result contraction is performed. Then it shows the result on the UI with the help of backend, that is a Flask API. Then come to project overview, that is innovative web-based solution combining the image and text-based classification for the accurate snake identification. And significance is to address the critical public health concerns in India, where snakebite related deaths are prevalent, and support wildlife management. There we use the different technologies. We also make a AI agent which accurately identify the types of a snakes based on the feature. And second one is the image classification powered by CNN model based on the model mobile net v2. Then model performance. Our model achieves 71 accuracy with a MobileNet V2 and 80% accuracy with a Venom model. Application Applications are it enhances the snakebite management by quickly identifying the venomous species, and it also promotes the ecological studies. It impact AI powered platform for a real-time reliable snake species recognition and aiding both professionals and general public. These are the results. This is the UI which we created. First figure shows the user interface, that is a Venom alert, identify the species of a snake based on image, and second figure shows the output on the user interface. We can upload, or user can upload the image in this block which is shown here, and the button indicate the species of the snake, and second button indicate whether the species is a venomous or not venomous. This slide show the working of AI agent, and figure 3 shows the agent interface. On this agent interface, we query the different features of the snakes, like based on the snake appearance, such as its pattern, color, head shape, pupil shape, scale, size. We query these features and it gives the output or the species of the snakes based on the input provided by us. It takes those features and asks the dataset or dataset provided by us and provide the accurate result or accurate species of that snake based on the feature which is match our query. Then conclusion. Our project signifies an important advancement in the addressing the public health challenge posed by the snake bites, which are esteemed by the World Health Organization to over millions of times annually. In conclusion, Venom Alert is vital innovation in the public health, addressing the critical issue of a snakebite related mortality. By integrating cutting edge deep learning with a user friendly web interface, we provide a fast, reliable
Hello everyone, my name is Athra and today I am going to explain how we train the models for our project Venom. Let us first look at our Venom classification model. Here we have imported all the necessary libraries such as OS for interacting with the file system, NumPy and Pandas for mathematical computation, TensorFlow for deep learning application, and the various layers we are going to add to our CNN model. Here we have given paths to our dataset. These are the paths to the directory and these are paths to the CSV files. After this, we load the CSV files and construct image paths, which combines the base directory and the class ID. Next, we do mapping from class ID to indices, apply the mapping to the data frames. After this, we give constants such as image width, image height, the batch size, number of species, and the batch. After this, I have created a function to load the images and the labels. This function loads the images and labels, reads images using load image, normalizes pixels, and retrieves class ID. And after this loads the training and testing data in the memory for the model training. Now let us look at our main model. The base model we have used for the Venom classification model is Inception Transnet V2. We have frozen the first 20 layers of this model, and we have added our custom layers such as global average pooling 2D, which reduces the feature maps to a single feature map, that is dimensional reduction. After we have added the dense 128, which is a fully connected layer with ReLU activation for learning patterns, and we have added dense one, which is output layer with sigmoid activation for the binary classification, venomous or non-venomous. After this, we compile the model with Adam optimizer and set a learning rate of 1e minus 4 and train the model. Look toward our species classification model. Here also we import all the necessary libraries such as OS, NumPy, Panda for mathematical computation, TensorFlow for deep learning. And we have also loaded all the layers we are going to add. After this, we are given paths to our dataset, and here we read the CC file. After this, we do data augmentation. We have used image data generator to prepare images for training with augmentation. The augmentation we have done are the rescale, the validation split, horizontal flip, zoom range, shear range, and rotation range. After that, we split the training data into 80% training data and 20% validation data. Next, we go to our model. Our base model is MobileNet V2. In this base model, we add the following layers: global average pooling, which used for dimensionality reduction; dense 1024, which is fully connected layer with 24 neurons for additional learning; and dense activation layer with softmax. After we freeze the base layers to ensure pre-trained features are not modified, and compile model with all Adam optimizer and start training. After this round of training, we unfreeze the last 20 layers of the model for fine tuning. We load the model again with the Adam optimizer and with the learning rate 1 minus 5 and retrain the model. After this, we evaluate the model and plot the confusion matrix.
Everyone, my name is Sejal Wankede. Today I'm going to show you the work I have done on the backend side of this project. First, we import all the necessary libraries. Flask is the backbone of our web application. The Pillow library handles image processing, and TensorFlow is used to load and work with pre-trained deep learning models. We also use NumPy to handle image data as arrays and OS for managing file paths. Next, we set up our Flask app and configure to store uploaded images in the static/uploads folder. We also define the allowed file types like .png, .jpg, and .jpeg to ensure we only accept valid image files. Here, we load two pre-trained models, one to detect whether a snake is venomous and the other to classify the snake species. These models are stored locally, and we use TensorFlow's load underscore model method to load them. This is the list of snake species corresponding to the output indices of species classification model. The allowed file function ensures the uploaded file has a valid extension like .png or .jpg. This is our first layer of validation. Next, the preprocess underscore image function prepares the uploaded image for the model. It resizes the image to 224 into 224 pixels, normalizes the pixel values to a range of 0 to 1, and expands its dimensions to match the input format expected by our models. This is the core function. It makes predictions using both models. First, it checks if the snake is venomous. If the venomous probability is greater than zero point 0.5, it is classified as venomous. Otherwise, it's non venomous. Next, it identifies the snake species by selecting the index with the highest probability from the species model's output. The home route serves the html.html file, which contains the frontend where users can upload their snake images. The slash upload route processes the uploaded image. Here is how it works. It checks if the file is present and has a valid format. The file is saved in uploads directory. Then the predict underscore snake function is called to classify the snake. Finally, the species name, venomous, status, and image path are returned as a JSON response. Lastly, we use run app.run method to start the Flask application in debug mode, making it easier to test and troubleshoot. Now let's see the working model